In 10.3, number 14, there's an equation that's quadratic in form. Rather than solving it by substitution, however, this type is easier to solve as a rational equation. Remember that negative exponent just means that the x could be in the denominator with a positive exponent. So 3x to the negative 2 is the same as 3 divided by x squared. And x to the negative 1 is the same as putting an x in the denominator. So if you write this as a rational equation, you can multiply both sides of the equation by the least common denominator, which is x squared. So we'll multiply both sides of this equation by x squared. So as you do that, every single term gets multiplied by x squared. The x squared we're multiplying by is in the numerator. So if you wanted, you could think of it as an x squared over a 1. So you get an x squared in the numerator, and that x squared in the numerator will divide away the x squared in the denominator. On the right, 0 times x squared is 0. So you end up with 3 minus 11x minus 4x squared equals 0. This can then be solved using the quadratic formula or by factoring. I'll go ahead and see if I can factor, but first I'll multiply both sides of the equation by a negative 1 and write this in descending order. So I'll have a positive 4x squared, a positive 11x, and a negative 3 equals 0 there. So I'm going to see if I can factor. The negative 3 would have to be 3 times a 1, and one of those needs to be negative to get a negative 3. The 4 in the meantime could be 4 times 1 or 2 times 2, but I see if I put a 4x and a 1x that my outers will be 12x and my inners will be 1x. So let's make that a positive 3 and a negative 1. So now when I go to check, I have first terms 4x squared, outer terms 12x, inner terms negative 1x, and last negative 3. Exactly what I needed. So we'll set each factor equal to 0 then. 4x minus 1 is 0, or 1x plus 3 is 0. Here x is negative 3. Here we add 1 to both sides of the equation and divide by 4, so x is a fourth. So the two answers are 1/4 and negative 3.